remote code execution vulnerabilities in Cisco UCS, which is the server management, all the nexus from 7,000 down to the virtual thing in the CGR. And yeah, people can run code in kernel. So lesson to be learned. If you invent a protocol, you better write a fucking correct parser before you ship it. Thank you. Now, okay, if you suck, there's always encryption, right? You can always encrypt stuff. So the VSM actually stores, like the supervisor module stores a bootstrap core configuration on the vServer, vCenter, the central management system. For no apparent reason, because it actually uses a couple of megabytes on his virtual flash and synchronizes that to the backup VSM. No idea why they needed to have some part of the configuration on the vCenter. But when they talk to the vCenter, they use SSL, and Cisco being the only thing in the vSphere cloud that doesn't check the fucking certificate. Thank you. So if you can provide this bootstrap, then essentially you control where the VSM goes after that, and then you own the virtual networking. Talking about the communication, so remember that I said this backplane that used to be just an electrical connection between a supervisor card and a line card is now on the network. So that means it uses a protocol. There's two versions, like how you can configure that. There's a layer 2 version, which is a 802.3, so not what we usually use on IP, but the older version, protocol that talks broadcast the entire time, probably because they want to sell more hardware switches. Your physical network actually gets unusable if you have those. And there's a layer 3 version, which is needed for the hipster cloud configuration SDN shit, which talks UDP. Now, what they do over that is the control channel. Obviously, you need to control your line cards. Say, like, this is the new MAC table, this is who you talk to, this is who you not talk to, blah, blah, blah. And they have a packet channel where they transport very important packets. Not all the packets, just very important packets. CDP, IGMP, and LICP. But mostly CDP, every 30 seconds, everyone. Anyway, so this protocol is completely undocumented. And the nice thing is when you live in Germany, reverse engineering is, even in civil law, not attackable if you do the reverse engineering in order to ensure compatibility to a open source project that you're working on. So we want to write line cards for Cisco. Trust me. So I looked at that protocol. So you look at the protocol and you see, okay, there's different types of transfer and subtypes. The one that immediately caught my eye was FTP. Good, fine. So there's a direction. Is this from the VSM to the VEM or the other way around? What format is it? There's 7 bits to encode 2 states, raw or encrypted. There's a domain ID, which means to which switch do I actually belong, and there's a ISAC version. ISAC is the encryption that they use. The version is always 1. There's an ISAC key version. Which key do I use for this encryption? 1. And there's 2 bits that say, I'm encrypted and I'm HMAC'd. If you set them to 0, the other side says, well, okay, you're not encrypted and you're not hashed. Let me parse the packet. Why the sender decides that is beyond me. But good. Now, this is what we have. Now, if you ever ran any Cisco equipment, you know the most important command that you can have is called debug. Because shit doesn't work, and then you debug until it does. So, of course, on the ESXi, there's also debug. In this case, it's called vemlog. And when you turn on debug on Cisco code, it usually means that they take values out of packets and use them as an index in an array, which they do here. Unfortunately, that array is not as big as the value could possibly index. This being kernel modules, this is what happens. If you haven't seen this before, this is called a purple screen. That's the blue screen version of an ESX host dying, like everything that ran on it died. Daniel just smiles at me. He's seen that. So this is target description if you ever go into VMware hacking. This is what you want. So, okay, so this being a read exception, I couldn't be bothered to find out if I can exploit it because there was more, but it shows you the type of vulnerabilities because, let me go back to that. The thing is, you can do that from a guest account in a virtual machine, right? So you send a broadcast packet and everything that goes pink, is now yours or potentially yours. There's logic bugs as well. So how does a VEM, like this virtual Ethernet module, identify itself to the virtual supervisor module? Well, I'm running on a host, so let me take something that identifies the host. Let me take the hardware UUID. UUID is a big, scary number, very unique. Cisco actually opted to take the only ID that you can find on an ESX host that you can query by multicast SLP from a command line anywhere in the network. Because if you do an SLP query, who has ESX installed here? The answer is the hardware UUID. Very bad choice for a secret. Very bad choice. So essentially you take that UUID, you put it into a packet, you send it to the VSM, you become the VEM. I just became a Ethernet module. Just a second. Later. So, I need to hurry. Good. Where were we? So what you can also do is if you run the layer 3 configuration, like the UDP configuration, I can see that for a network core equipment vendor, it's really hard to do traffic rate limiting. This is why Cisco didn't do that. And so simply flooding the UDP port that they communicate on means that the VEM is actually not visible to the VSM anymore and gets dropped from the virtual switch configuration. You can do that. Now, encryption. Let's get back to this backplane. This is critical, right? It used to be in the enclosure, in the box, in the computing center. This is where all the backplane communication happens, right? Now, this is on the network. So at some point, they obviously realized that, and the documentation says it's 128-bit encrypted, period. End of statement. Imagine you usually have sex in private, and then you do it up front here. And then when the girl says, like, is anyone seeing us? No, we are encrypted. It's good. Obviously, I look at that. It turns out to be AES CBC. I look at the code. It's using OpenSSL. I'm like, thank God. They used OpenSSL. They didn't write it themselves. You read a little bit more, and so every time a packet comes in, like a frame comes in, they reinitialize the key and the initialization vector with a fixed coded value, which needs to be the same across the whole product line, which it is. Oops. The HMAC, the bit that you can set saying this is HMAC, turns out to be SHA-1. Now, I'm not a crypto person. Greg is the crypto person. The problem is, even I know that if you want an HMAC, there needs to be some secret. It's not there. It's just a SHA-1. Good. So now we can actually decrypt the traffic. And that means this protocol being called stun, this has some stunning impacts because we can also encrypt the traffic. That means we talk on, like, we do the same thing as if talking on the backplane of a 65,000 series Cisco Catalyst switch. It's nice because we can tell it, look, this and this port runs the management network, and this is where the vCenter is on. Give that to me. Thank you, I manage that for you. It's good. So we can man in the middle all the traffic, which is nice because there is no PKI and people get trained in VMware trainings all the time to say, ignore, remember decision. And you know, there is ways to actually secure this. If you VLAN everything completely out and you have never a single mistake in your VLAN configuration, it's fine, you can run this. If you ever ran a network bigger than one switch and you're looking for the perfect VLAN configuration that never fucks up, you know what I'm talking about. Okay, so the fun part is there's layer 3, the UDP version, which is required if you want to run hipster clouds, SDN, or if you want to have a vSphere 5 certified cloud. There is a thing called that. This requires you to have layer 3 on because it requires you to have, instead of VLANs, VXLAN, or as I call it in German, VXLAN, which is the base requirement for SDN, software-defined network. This is not defendable, actually, because it uses the same key. So the worst case scenario is what everyone does right now. It's like, everything else is virtualized, but we're just, we're on the trip to virtualize everything. So what's this metal here? Oh, DMZ. Let's virtualize the DMZ, put it all on one host, we're good. This is this gray box, this is what everyone does. So let's assume you virtualize your DMZ. You have a couple of web servers. On one, the intern has a non-privileged account. He puts on PHP and a bulletin board. He welcomes the 500 other administrators for the bulletin board. And they, one of them actually uploads a new PHP script, which sends one UDP packet. So he owns the web server. Sends one UDP packet, to the virtual switch element, takes over that port group, and builds a tunnel into the internal network. This is the Chinese RAT, remote administration tool. So this is what actually happens. Now, you can fuck up one product. You can actually fuck it up that badly. Maybe everything else is better. So I randomly grabbed the image for a NSS 2000, which is a SAN, network attached storage device from Cisco. Firmware, recent, it's again a Linux. It has web management. You look in CGI bin, you actually find obfuscated Perl scripts. I'm old enough to remember when we stopped doing that. Turns out the code was actually older than I. It's actually PMC Sierra code from, I think, end of the 80s. So every time we see Perl code, so I wrote the deobfuscation engine in 30 minutes. And I'm the worst coder under the planet. So, that was great. And when we see Perl, we give shit to FTR. FTR looks at the Perl code, sends me an email and says, the Perl code was funny, but did you look at the initial PHP file? Where you get code execution by the password? Like the wrong password? Like your wrong password actually gets executed on the shell. Okay, put it in the clouds. So there's also the Cisco Prime line management solution. This is again not a bug that we found, but I loved it because suddenly you find a bug in a Cisco bug management system that says, well, then we have a security issue. We bind root shells on a TCP port. What? It's almost like this joke where, I don't know if that translates. The female goes to a doctor and says, like, I have a knot in my tits, and he's like, who will do that? So really bad. So concluding, and here's why I'm wearing this, shirt that actually competes with my face and ugliness. Cisco P-Cert, again, was really beautiful to work with. They're like the only smart people in the entire company. This is the bug IDs, if you want to look at that. When I last gave this talk, what happened was a week ago, I found out like all those bugs were set to fixed. Because all the cloud using people were looking at the bugs going like, this is evil, you need to do something about it. Fixed. Good. P-Cert actually reopened them for me a couple of days ago. So like, give a round of applause to Jaken, please, because he's like new to P-Cert and he's the only one. So he fucking reopened the bugs and said like, no, this is not how that works. Like, you need to fix the bug. So we reported them in November 28 after a lot of consideration. In July this year, they introduced the one if statement that fixes the easiest bug. The encryption issue, which essentially allows everyone to own your cloud, is going to be fixed. No, first of all, it's not an encryption issue. It was renamed by the product team during a phone conference I had with them to the, how did they call that? The basic security architecture. And by 2014, sometime 2014, they're expecting to have an enhanced security architecture. Probably just using a different key. This is the talk. I do have 4 bonus slides, if anyone wants to see them. Sehr gut. Yeah, cycle penis. So, okay, bonus slides. Not actually really related to cloud, but Cisco. So, everyone talks about NSA and Prism and stuff. So, now some anecdotes. The way most of the Secret Service acquisition systems work is the NSA never broke, as far as we know so far, any laws, right? They just went the legal way and saying, okay, here's lawful interception. We need to lawfully intercept everyone. The saying at the NSA is, in God we trust, everyone else we monitor. So the way they do that is they use the technology that is built into our core networks in order to, find terrorists and people that copy MP3 and other evil people. So the way that works is you have a so-called mediation device, which is a regularized server that speaks SNMP to your routing infrastructure. And on a mediation device, the lawful interception, law enforcement agencies will log in and say, like, I want to watch this guy watching porn. And this configures this request and sends it to the router. After many years, I successfully obtained 2 iOS images that are perfectly equal, except for the LI functionality. And so the thing is, nobody, not the provider, and certainly not the state, will actually pay money for that functionality. So the provider goes like, why would I buy a bigger router just because the police wants to watch this guy watching porn? So how can I get cheaply out of this? And that's what motivates the vendor and blah, blah, blah. So nobody wants to pay money for them. The problem being that routers actually die if you want to monitor someone, because they're built to quickly get rid of the packet, not look longer at it, right? It's pretty much almost like you need to memorize medical exam information while fucking. It's either one or the other. Like, either you have throughput or you parse shit. So this is critical path. Like, this is where the packets get into the main CPU and clock everything. So it turns out that this diff, and we're talking about 138,000 functions in the entire image, the increase is only 257. That's very little if you want to intercept IPv4, IPv6, VoIP. You have to support a shitload of mediation devices. The ones I saw in Germany were running Sonos 5 with a CDE interface. And that's just very little functions for that amount. So what they do is they use ACLs, extended access lists, on Cisco. Now, every time Cisco invents a new line card or forwarding technique, a year later they find out that their extended ACLs don't work. Because someone forgot that if you have an ACL, you actually need to ask the ACL whether this is fine to forward. We had that with the license issue. So if you find out that any routers in your internet provider's environment have ACL issues for certain formatted packets, let's say there's a discrepancy between the amount of data your recipient receives and certain nation state actors. Also, this is done over SNMP v3, and it's mandated by law and by the RFC that what Cisco actually wrote, that the network operators are not supposed to see when a lawful or less lawful interception agency watches you watching porn. The problem is they still need to configure the password. So you should keep in mind that, well, there's NSA, but the NSA provides their intelligence to one black guy and one white house. The network operator set the same password and knows the SNMP MIP, and he can watch you watching porn whenever he thinks that's porn for him. Now, how does that look like? This is a check interface. They were friendly enough to put it online. So whatever you want, it's ease of use. And whoever you are, it's ease of use, right? Doesn't matter if you're Unicode or not. You just say, like, this guy, dare, this porn, watch. Now, how does that work? I looked at that code and I invented the IPv5 laser light. So, you know that laser light actually doesn't pass through prisms? So, this is actually code from the lawful interception interface. I would like to put your focus to the right side, which says, like, let me look at the IP version, the first 4 bits in a packet. Is that 4? Cool. Let me copy an IPv4 packet. Is that 6? Let me copy an IPv6 packet. Otherwise, let me copy nothing. Turns out, depending on what your reception stack is, And depending on what networks you have in between, it can be totally fine to put version 5 in an IPv4 packet in the first 4 bit. Because Ethernet will already transport the information in a packet type that this is IPv4. So many stacks, and especially many hardware implementations, will go like, v4, cool. This is what I call laser light, because it's not going to hit Prism. Now, on the VoIP thing, this being an application layer gateway, we have similar code. See this here saying network start is below data area. So there's a very simple way, which will be obvious by now, how to encode your voice stream over ZIP or other teleconferencing modi, so that the packet gets not copied. Because what you see here on the right is a very, very long piece of code that copies the packet to the police. And this here jumps to exit. Packet not copied, packet not there. Now, the most brutal way to find out if you're monitored or not is this. As I said, routers they're trying to get rid of the packet as fast as they can. The bigger the router, the more money you spend on it, the better it is at getting rid of people, right? Like hedge fund investors, to get rid of people, employees, really quickly. The problem is when you actually have the packet going all the way up to the main CPU. This is called punting. It's called punting from like la la la, the Venetian way. It's called punting because if you do that more often than, let's say, once a second, the router dies. Because it's already running on 60% CPU load anyway. If you punt a couple of packets, it's software forwarding packets, so it goes like, yeah, so it reacts like, a Windows machine when you start OpenOffice. The thing is, this code, Cisco doesn't want this code to be there. Their customers don't want this code to be there. So they try to get out of it as fast as they can. However, if they miss a packet and law enforcement comes in later and says, you fuckers, this packet was important for, and now he is a terrorist and he's free and whatever, that's bad. So they have to add code. When they say, blah, 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 protocol scale failed, punt means they put it up to the main CPU. Meaning, essentially, if you want to find out if your LI intercepted on a router between here and where you want to talk to, build a couple of those packets at Scapy and send them. If your trace route changes, because one of the core routers on the access layer just reboots, and that's actually all bonus I have. I am willing to share this particular diff with anyone who wants to research this. As you've seen, it's not a lot of functions, but it's an alternative way to deal with that problem. Thank you very much for coming at that late hour.
Check, check. FX, did you want to take questions? We have a little bit of time for that if you'd like.
Did I suck so much?
No, you were awesome. They just needed the VGA adapter in tent 1.
He looked like the device was actually burning. Good. Questions? As usual. See, this is why I had backup slides.
Well, shall we drink?
Shall we actually get drunk?
Sounds good, but before we do that, let's give a huge thanks and a round of applause for FX for an amazing fucking talk.
if you came here to be sober, why didn't you stay home?